Welcome back. We're going to continue our discussion on moles, grams, atoms, molecules, etc. So these are the four terms that you probably would see consistently from now onwards. So let me write those four terms. Okay, we've looked at three. Okay, grams, moles, atoms, and molecules. If there's a way to say that, a lot of the chemistry is, encompassed within these four terms, okay, molecules. Okay, so we have looked at the first sequence where we started with grams, and if you're starting with grams, you're going to use the molar mass. As I said, that molar mass is the starting point of going into moles, and then we use the mole is 6.022 or 6.023 e to the 23 atoms, and then we end up in atoms. Okay, this is our final destination. We're still going to use the same sequence for the learning that's going to happen here. So let's say we want to find out how many, okay, this is a multiple problem. So how many carbon, oxygen, and calcium atoms are there in 2 grams of calcium carbonate. Right? Now, we want to know how many of carbon, how many of oxygen, how many of calcium atoms are there in 2 grams of calcium carbonate. Right? Now this right here is a molecule. Okay, this right here is a molecule, right? So there is only a slight difference, okay? But I'll point that out to you very quickly. But first we got to determine the molar mass of this molecule. Okay, so let's get the molar mass calculated first. Whether you use it or not, go ahead and calculate it so you get into the practice of it. So calcium's atomic mass, I believe, is roughly around 40. Again, don't get bogged down. Oh, the periodic table says 40.08. Use it. All right. So I am used to it. So I'm going to stay within my comfort zone. So it's 40 grams per mole. Right? Which is same as writing 40 grams over 1 mole, right? Both are correct representations. Carbon, 12 grams per mole, which is same as writing 12 grams over 1 mole. And then oxygen is 16 grams over a mole, which is same as writing 16 grams over 1 mole. To calculate the molar mass, simply add them all up. So total molar mass equals 40 plus 12 plus, careful here, this is for a single oxygen, 1 oxygen, okay? But how many oxygen are there in the molecule? There's 3. So 16 times 3 is 48. So that'll be 48 plus 12 is 60. 60 plus 40 is 100 grams over a mole. Or 100 grams over 1 mole. That's the first step in doing the math. All right, so we've got the molar mass down. So let's go ahead and okay. All right, so let's go back and rewrite the question, okay? How many carbon, calcium, and oxygen atoms are there in 2 grams of calcium carbonate, right? Okay, so, well, you have to do one at a time. All right. Now, if you have a molecule, okay, let's do something here. So you always start with the given information, okay? So we've calculated the molar mass in the previous screen. So molar mass of calcium carbonate is, we said, is 100 grams over a mole, okay? Over a mole, right? So we're starting with 2 grams of calcium carbonate. Now that 2 grams is for the entire calcium carbonate, and then we're going to draw our tic-tac-toe box here and then write 1 at the bottom. Okay? Now what do we want, or what are we going to? Okay, we're going to atoms and we are starting with grams, right? So we are going from grams to atoms, right? That has not changed. Okay, but we are dealing with a molecule here. So first we got to get rid of the gram, and for that we're going to use the molar mass. So 100 grams goes on the bottom, 1 mole goes on the top, right? Good. So what's the conversion here? Okay, let's think about this. We are canceled out the grams, but we're now left with moles, right? Now a mole, right? Right? A mole contains also 6.022 e to the 23 molecules. Now, this is where some of you might be thrown off, but just hang on and I will provide answers to that. All right, so we can now cancel out the moles. Okay. Now a molecule, okay, a molecule of calcium carbonate. A molecule of calcium carbonate. This is a molecule, 1 molecule of calcium carbonate. Let's say we're dealing with carbon. Okay, we're calculating the number of atoms of carbon. Okay, so a molecule contains how many carbon there is? How many subscript is next to carbon? Nothing, just 1. So 1 atom of carbon. Okay. So let's calculate this. So it's 2 divided by 100, okay, times 6.022 exponential 23 times 1. So that will be 1.20 e to the 22 atoms. Now, before we go further, let's stop here and discuss what we have done. In the earlier case, we have gone from grams to atoms, and I gave you the sequence. It still is the same, okay? But when you're calculating the number of atoms of a particular element in a molecule, you have to make that subtle difference. So you're going to start with grams, okay, and you're going to go to molar mass, just like you did, okay? And instead of a mole, we're going to use a molecule. A molecule, okay, sorry. Okay, we said a mole contains so many atoms, right? But this time we're going to write the same number, but instead of molecule, instead of atoms, we're going to say molecules. Okay, and then, okay, you multiply by however many atoms of that element, okay, how many element is present in that molecule, and that will give you the answer in atoms. Okay, we're multiplying by how many element there is in that molecule. I don't want to write in the molecule because I want to keep the sequence as concise as possible. Again, I'll write the same sequence again when I calculate it for oxygen and calcium, so you have it in 2 different places, right? Very good. So let's go ahead and, okay. So let's go ahead and get our, we're going to do this now for oxygen. And we know the molecule we have is 2 grams of calcium carbonate. And we know the molar mass of calcium carbonate is 100 grams over 1 mole, right? Right. So we're going to do the calculation on how many atoms there is. So 2 grams of calcium carbonate to number of oxygen atoms. That's what we are essentially doing. That's what the question asked us to do. So as I always said, you start with the given information. And if you see, I'm being systematical, maybe not with the colors I use, but I'm systematic with the content, the way it's presented, right? You always start with the given information. And you see, I don't just write 2. I see students writing 2. Are they write G? Are they write CaCO3? Oftentimes what I see is they just write 2. What does the 2 mean? Okay, what does the 2 mean? It means nothing, right? So we write 1 on the bottom because there is no information to fill that space with. And then the next piece of information obviously is the molar mass, because that molar mass is again for the calcium carbonate, is not for just calcium, carbon, or oxygen. So it's 100 grams, okay, of calcium carbonate is in 1 mole, right? Again, why are we flipping it? Because that's the only way we can get rid of the grams on that first column. So let's go get our pink. Okay, so we have now, canceled out the grams, right? Now we're left with moles. Now keep in mind, this is where you got to be careful. The sequence is the same, but we have to make that little change. Remember, a mole of calcium carbonate contains 6.022 e to the 23 molecules, not atoms, because we are trying to find atoms in a molecule, so it can be atoms. All right, let's go get our different color again. Right, so now we can cancel out the moles with the moles, right? Now molecules. We got to get rid of the molecule. A molecule of calcium carbonate, a molecule, that is 1 molecule of calcium carbonate, contains how many oxygen atoms? There's 3, so 3 oxygen atoms. So that will be, it's 2 divided by 100 times 6.022 e to the 23rd times 3. So 3.61 e to the 22 atoms, oxygen atoms. Okay, right? That's how we do it. Now last one, calcium. And 2 grams of calcium carbonate, right? That's what we're starting with. Okay, and we're gonna just put a 1 because there's nothing else to fill there. And then we got to get rid of the grams, so we go to the molar mass. So 100 grams of calcium carbonate, and then is 1 mole. And then we canceled out the grams now. Now let's go get a different color. And so a mole of calcium carbonate contains, only difference you have to make when you deal with an element and a molecule is this right here is exactly the same. Okay, but for an element, we write atoms and the step actually stops right here. We don't go any further, right? But for if you're finding atoms in a molecule, you have one more extra step, and you also have to make sure this doesn't read atoms but molecules. All right, so let's go get our last color here. And so now you canceled out the moles. We're left with molecule. A molecule of calcium carbonate contains one calcium atom. So that'll be almost same as the exact value that we had for, I believe it's 1.22. 1.20 e to the 22 atoms. E to the 22 calcium atoms. Okay, this here the molecule has canceled out. Now let's summarize the two sequences. So if you're just dealing with a single element, okay, like nitrogen, oxygen, it's just an element, then the sequences, you start with grams, you use the molar mass, okay, and then you have to use the mole to atom conversion. So 1 mole is 6.022 e to the 23 atoms, and then that will finish you off at the final destination of atoms. So this is the starting point, this is the ending point. These are your conversion tools. These are just merely conversion tools. Okay. Okay. So that's the one. And okay. And so if you're dealing with atoms, if you want to calculate atoms in a molecule, okay, atoms, there's two steps: calculating atoms in an element and calculating atoms in a molecule. Okay. Then you start with grams, right? And then you go to molar mass, right? And then instead of it, you write 1 mole as so many atoms, you write 1 mole is actually 6.022 e to the 23 molecules. And then before you go, you multiply it by number of that element, number of elements. Okay. And then you end up at the atom's destination. Now again, as I said, whatever you see in the highlighted pink boxes are primarily your conversion tools. Okay. And this is the last one. Okay, so let me give you some problems to practice. So let's write practice. Okay. Okay. Calculate, okay, number of, okay, hydrogen, sulfur, and oxygen atoms in 2.5 grams of H2SO4. That's a practice, and I will provide likely a answer to this problem in the next video, and stay tuned. Okay, bye-bye.